we've got this. A is rotating, and you have B. The whole idea behind this one is this is going to be the point that connects A and B. That point right there is going to translate all the way over here. See what I'm saying?
Mm-hmm.
And so all the motion along this piece right here has to be what's connecting them. So the touching point is what has the touching point is where they share the motion. The point of contact is where the motion is shared.
Mm-hmm.
It's the same. But when you're looking at a rigid body, any point on the rigid body has to be seen in its linear as a linear data. Okay. So
Mm-hmm.
I'll put for bodies rotating, any point on it must be looked at, must be seen in linear terms, which means you're going to go from the W, which is for the body, and then it's going to be going to V for the point. So there are points on the body. The whole body has a W as evidence as such. But this point, we're going to say has a velocity. And so what we do is we say that is going to correspond to a V. The V of the, let's just call it 0.1. We're going to call it V1. Make some sense? Or V1 equals W of A times by R1. You following me?
Yeah.
And obviously, if you were to draw it to acceleration, AT1 tangential of 1 is equal to alpha of the body times by R1. Okay, and the normal of 1 is going to be W squared of A times by R1 like that. You follow me?
Mm-hmm.
Dope. So V1 is what translates all the way down here. So V1 has to be V2. So this is the point right here called 2. V1 has to be V2. That is our star piece of data. That is our star piece of data. Oh, that's not, that doesn't work. That, come on, is our star piece of data. This right here is our star. V1 is V2, and also AT1 equals AT2, because that's going to represent, that's the only thing where they're touching. So they have to be the same. Anything that touches have to have the same values. Otherwise, you're going to produce a skid or a discontinuity at that point. That's going to make the math more difficult. It doesn't make it wrong. It just breaks down assumptions. And we need those assumptions based on touching points. That's how we relate everything in reality. And you're going to see that more and more as you do more engineering past dynamics. So like when you see it in thermodynamics, you're going to see the skin that represents the barrier between them two, that has to be the same temperature. Otherwise, it's going to break down. Same thing goes for like electromagnetics. When you start seeing electromagnetics, or in fluids, you start seeing in the fluids, they call it the skin effect in fluids. And so you see that the same idea of the point that represents where the two objects touch has to have the same for both of them. That's the connecting idea. That right there is consistent in all engineering. You're going to see it more and more, and it's going to make more and more sense as you see it. But although the data for 2 is the exact same, WB R2 AT2 equals alpha B R2 AN2 equals WB squared R2. But the thing is, we know that this guy and this guy and this guy and this guy are related. You know what I'll do? I'll put them in I'll do it like that. That guy and that guy, and then I'll say this guy and this guy are equal. So I'll say equals and equals. So what you end up having is a relationship that takes you from one equation to the other. See how that works?
Mm-hmm.
And that's why the motions are related. Okay, and so that's
Okay.
the idea behind A and B. Outside of that, once you know that alpha equals constant, which it is in this problem, use the constant acceleration equations. Delta theta equals W naught. It's the same. It goes back to the same equations we did up before. W naught times T plus 1/2. Instead of A, you use alpha. V, you use W. And S becomes theta. So this becomes W final squared. Is W initial squared plus 2 alpha delta theta. And then alpha equals D or delta W over delta T. Well, that data all of this stuff just is going to run inside of that. But if you can't understand this right here, you're not going to get to the answer. So I would always say focus on this. And once you have an understanding of all the V's and the W's, then you can back solve it and plug it into that if you want to.
So my thing is that essentially, like, if I'm asked for the let me see, the angular velocity of pulley A after it turns like a rotation, which is pi, right? Because pi is one rotation.
2 pi.
2 pi is
One
rotation,
rotation
but
is 2 pi.
it says pi, so that's half.
Yeah, half rotation.
It says pi, so it's half. So that means that so the answers that I solved for in there, right? So literally for A, once I find A, like it'll be the so wouldn't it be the same answer for both of them? Like if it was like the angular velocity of B, it would be the same answer as if they asked for the angular velocity of A, right?
No. Only the linear terms are the same. The angular terms are not the same. So the W of B is not the W of A. And that's what this means. W of B is not the W of A. And it's because of this.
Mm-hmm.
V of the point touching B and A are the same, but the W's themselves are not the same. So what you would do